So, here are the first four, ladies and gentlemen. Calcium nitrate. Again, when you see that ATE ending, ladies and gentlemen, you've got to turn your periodic table over. ATE, ITE endings, you have got to turn your periodic tables over and find the polyatomic on the back side. There are some polyatomics that do end in IDE. So if you have something like cyanide, there is no element cyanide on the board. So when you can't find the element, you've got to turn your periodic table and look for it on the back. There are about 5 that end in IDE, but if it ends in ATE, ITE, you have got to know to turn your periodic table over and look at the back. Okay? Calcium is a +2. Nitrate is a -1, so we end up with CaNO3 in parentheses with a 2 by it. Questions? Gallium phosphite. Gallium is a +3. Phosphate is PO4. It is a -3. To make it phosphite, we lose 1 oxygen. That becomes PO3. The 3's cancel out because of the fact that we can reduce them. That is why it is GaPO3. No parentheses around this because we don't need them. Tin 2 sulfate, ladies and gentlemen. Tin is SN, sulfate is SO4. Sulfate is a -2, tin is a +2. We know that because of the Roman numeral 2. Therefore, when we bring the 2's down, we would cancel them anyway. So that is why it is SnSO4. Ammonium nitride. There is no element ammonium on the periodic table. There is no element ammonium. And if you are beginning a name, it will always be in a covalent or in an ionic compound. It will always be a metal or ammonium because ammonium is the only polyatomic that I have given you that has a positive charge. So ammonium is NH4. It's a +1. Nitride comes from nitrogen. IDE ending means that it's a lone element. No NO3, no NO2, nothing like that. So nitrogen is a -3. We bring the 3 down by the NH4. It has to be in parentheses. There is your formula. Questions, ladies and gentlemen? Okay. Dinitrogen tetraoxide is a binary covalent compound, so we write down the name based on the prefixes. Di means 2, nitrogen means N. Tetra means 4, oxide means oxygen. N2O4, do not reduce this. This is a binary covalent compound. We do not reduce them, ladies and gentlemen. Zinc perchlorate. Perchlorate is one more than chlorate. Chlorate is ClO3, so perchlorate is ClO4. Still has a -1 charge. Zinc has a +2 charge. Again, I have given you that on your periodic table. If you get to a test and you cannot figure out what the charge on zinc is, call me over and I will tell you because I gave it to everybody already anyway. Okay? So, Zn, ClO4 in parentheses with a 2 by it. Questions, ladies and gentlemen? Trisulfur monofluoride, again, is a covalent compound. Binary, 2 elements. Tri means 3, sulfur means S, mono means 1, fluoride means fluorine, so S3F. Iron 3 hypocarbonate, hypocarbonite, because hypo and ite need to go together. Hypocarbonite means that carbonate has lost 2 oxygens. Carbonate is CO3. When you lose 2 oxygens, you become CO. So, iron has a +3 charge, carbonate has a -2, so we end up with Fe2, CO in parentheses 3. Any questions? Okay. Why do we use the crisscross method when writing a chemical formula? To get the total charge to 0. That is why we do it. It gets our total charge on our compound to 0. How do we recognize a covalent compound? It is between 2 nonmetals. It has prefixes. It is not reduced. Okay? You can't tell me there are no charges because we can't recognize that by looking at it that there are no charges. Okay? Questions? All right. On the back side, we wrote some names. So up at the top, ladies and gentlemen, PbOH4 needs a Roman numeral. The Roman numeral would be 4. It would be lead 4 hydroxide. Ag is silver. BO3 is borate. BO2 is borite, so silver borite. Al is aluminum. C2O5 is oxalate is C2O4. C2O5 has gained 1 oxygen, so that's peroxalate. NH4AT. NH4 is ammonium. AS is astatine. Astatine becomes acetyl. Questions? Good news, no one missed this one. Good job. Okay? So, sodium, Na, MnO4 is manganate, sodium manganate. PO5. This is not a polyatomic because there are only 2 elements here. Binary compound between 2 nonmetals. Phosphorus pentaoxide. No mono in front. We named the P for phosphorus. 5 is the prefix penta. O becomes oxide. NH4CN, ammonium cyanide, a polyatomic that does end in IDE. Questions? All right, so down at the bottom, ladies and gentlemen, what is the difference between an ionic and a covalent compound? Ionic, gain or lose electrons. They are between a metal and a nonmetal. Covalent, share electrons. They are between 2 nonmetals. How do we recognize a ternary compound? 3 or more capital letters. There is a polyatomic involved. They have an ATE or an ITE ending to them. I would have accepted any of those. Questions? All right, I will take back your quizzes for today. You can take and open your computers and get to our class notes, please. I will give these back to you to keep tomorrow, ladies and gentlemen. Thank you. Wonderful. All right. So, ladies and gentlemen, today we need to get through the last piece of our naming puzzle, and that is acids. So, we will get through acids today, ladies and gentlemen. Tomorrow you will have a chance to practice on them and ask any questions before we take our test on Wednesday. Now, a majority of the test, like 60 out of the 70 points on the test, is exactly like this, okay, or exactly like this. You will either be writing formulas or names for 60 of the 70 points, okay? 60 of the 70 points. There will be questions like you see on the bottom here. That will be the last 10 points or so of the test. And ladies and gentlemen, there will be about 6 or 7 points of bonus questions. Yes?
Wait, so why do you put the parentheses around this?
You put the parentheses because what the parentheses do is say, I need 2 of these groups.
Yeah, but for the CO.
Because I still need 3 of these groups. Oh. If you write down there is a difference between Fe2CO3 and Fe2CO3. Here is the difference. This compound is made of 2 irons. Okay? And 3, guess I can't do that. 3 of these CO groups. That is what this compound is made up of. Go ahead. Pass. Do a smart pass. Okay? That is what that compound is made of. Okay? If we write it this way, Fe2CO3, that says that there is 2 Fe's, a carbon, and 3 oxygens. Okay? So that is a very different compound. So the parentheses always go around a group so that we increase the amount of groups that are there, not just one of the elements within the group. Okay? So this way, the 3 only affects the oxygen. And this actually is a whole nother compound because this is CO3. Okay? This is CO, but there are 3 of them there. So anytime, and I know it seems weird, there's no number there. Why would we put it in parentheses? We do that so we never change the group. We do that so we never change the group. Good question. Other questions, ladies and gentlemen? All right. Then today, the other day, ladies and gentlemen, we got through, get it? Go. Okay. The other day we started talking about acids. How do we recognize an acid? What do we look for? AQ at the end. What does it begin with? Hydrogen. Begins with hydrogen, has an AQ. So if you're looking at the formula, begins with hydrogen, ends with AQ. Here's the good news. If you're looking at the name, they say acid in them. Every one. No matter what, when you name an acid, it says acid in it. Okay? So there are 2 kinds of acids that we have to worry about. The first is a binary. Binary means there are only 2 different elements in there. Binary means there are only 2 different elements. So what do you know one of them is? Hydrogen. So all you got to do is figure out what it's with. Okay? So hydrochloric acid, ladies and gentlemen. We write the symbol of the first element, which will always be hydrogen. It will always be a +1. We write the symbol of the anion and its charge. So what is the anion here? What does chlorine sound like? Chlorine. Okay? Chlorine. So this is hydrogen and this is chlorine put together. Okay? So hydrogen and chlorine when put together, ladies and gentlemen. Sorry. Wrong screen. Hydrochloric means hydrogen and chlorine. We still will do the crisscross method to balance off the charges. But here's the good news. Because hydrogen is always a +1, there will never be anything put by the anion here. Whatever the anion is, you're just writing it. But whatever the charge of the anion is, that's going to tell you how many hydrogens there are. Always. Always, always, always. So there's your formula, HCl, and it is AQ. Have to put AQ after it, ladies and gentlemen. Have to include the AQ. Questions? Now, when we're doing this, we still want our charge on our compound to be 0. That has not changed. So in that sense, bless you, we're treating this like an ionic compound. We're doing the crisscross method. We're crisscrossing charges. But again, the good news will be this is a +1, so there will always be a 1 by whatever the hydrogen is with. Whether it's an element or it is a ternary or a polyatomic ion. Either one. Okay. So now, hydrosulfuric. Okay. By the way, we haven't gotten there yet because we haven't introduced the naming system. But you will find that all binary acids begin with the term hydro. Not all acids begin with hydro, but all binary acids do. That's the symbol that there are only 2 elements involved when the name begins with hydro. So hydrosulfuric, what element gives us the sulfuric part of hydrosulfuric? Sulfur. So we're going to put hydrogen and sulfuric together, or hydrogen and sulfur together. Now, sulfur is a -2. So we still need to balance it off, which means it becomes H2S. We're going to drop our signs. We're going to drop our 1s because we don't write them. And our final formula is H2SAQ. So all the rules that we used before, the crisscross method, dropping the signs, removing ones. We're still doing that. We're still doing that because this is acting like an ionic compound. But the nice part about it is, with hydrogen being a +1, we will never put anything by the negative part of this compound. Okay? Now again, the negative part can come from any one of these nonmetals up here, except for one nonmetal, besides the noble gases. Which nonmetal will never be in an acid? Hydrogen. Hydrogen. Okay? Because there's already hydrogen in there acting as a positive ion. You won't put a positive hydrogen and a negative hydrogen together and make a hydrogen with no charge. Would not be an acid. Okay? Would be hydrogen gas. Okay? Questions? Okay? Hydronitric acid. Where does the nitric part of hydronitric acid come from? Nitrogen. Okay? What's the charge on nitrogen? -3. So when we're done writing our formula and we do the crisscross method, what would our formula be? H3N. Put the AQ after it, please. Put the AQ after it to show that it is dissolved in water, to show that it is actually an acid.
What about hydrogen makes it like the formula an acid?
What's that?
Why does like that the nitrogen just turn into an acid?
It's not the nitrogen that turns into an acid.
Hydrogen.
Why? Because hydrogen is acting like a +1 ion. And when you put this into water, it will increase the hydronium H3O plus concentration of the water. That is what makes something an acid. That there is this H3O plus ion floating around in your solution. That is what actually is the acid. Nitrogen is just along for the ride. It's just the negative part that happens to be attached to the hydrogen. The hydrogen is the important part, which is why all acids have to have hydrogen in them. Questions? All right. So all binary acids begin with the name hydro, and they all end with ic acid. So instead of ending in IDE, they're going to end with ic acid. So H and Cl, we begin our name with hydro. We have chlorine in there. We drop the ending of chlorine and it becomes an ic acid. So it becomes hydrochloric acid. That is where the name comes from, ladies and gentlemen. Now, I don't care where you write this, but somewhere on your periodic table, somewhere where you can read it very easily, I would put a note that all acids that begin with hydro are binary. Because the biggest mistake people make is, are they naming a binary or a ternary acid? And again, they get ones wrong because they don't put hydro in front of it. There is an acid called chloric acid. We will get to that. Hydrochloric is different from it. Anyone need more time? Okay. So now we have H3P. What is P? Phosphorus. So what is the name of this acid going to begin with? Hydro. Hydro what? Hydrophosphoric acid. Hydro and phosphorus from the H and the P. Change the ending to ic acid. So hydrophosphoric acid. In a minute, we will talk about phosphoric acid. Very different compound, ladies and gentlemen. Hydrophosphoric means there are only two elements involved, hydrogen and phosphorus. Questions? Now again, because we are back to charges, we are not using those prefixes, dis and tris and mono, okay? Because we're back to charges, we can figure out what the formula for H3P is, because P is a -3. H is a +1. H2S, what is S? Sulfur. So, hydrosulfuric acid. Again, there are not a lot of acids that are binary because there's not a lot of nonmetals to use over there. By the way, there's one other nonmetal besides the noble gases and besides hydrogen that you will never make an acid with. What is it?
Oxygen.
Who said it?
Oxygen?
Yes. Why?
I don't know, I guess. I mean,
What do you get when you put hydrogen and oxygen together?
water.
You get water. You don't get an acid, you get water. Good catch. Nice. Nicely done.
Me when I drink water.
All right. Hydronitric acid. Okay? Hydronitric acid. What does the nitric come from? Nitrogen. Hydrogen and nitrogen. Nitrogen is a -3. H3N, aqueous. Questions? Yeah, I think that's a repeat slide, isn't it?
Oh my god.
Thank you. But I don't know if these are. We'll find out in a second. All right. Grab a piece of paper. Write the 4 names for these acids down, please.
That sounds right. You should have walked upstairs. I would
Same information. Same information.
That's even weirder.
It's all the information I could find.
It's for
What is H?
Oh, we're waiting. So cute.
That's like a year old.
So you just decided to pull up the same notebook.
Every year she goes to like a month-long session.
Oh, that goes hard. Insane hard. The AI.
Yes.
Okay, my bad. That was so horrible. When we got on stage, dying on the floor. It was so funny. How are you supposed to stay?
Lucy, do you have a question?
Why did you not get that? You got a big dose. You did.
All right. What do all these names begin with, ladies and gentlemen? Hydro. Every one of them. So that is the most important thing. You've got to begin the name with hydro. All right. Phosphorus becomes what then? Phosphoric acid. So hydrophosphoric acid, ladies and gentlemen. Sulfur becomes hydrosulfuric. Now, I realize we are not dropping anything from sulfur's name, but hydrosulfic acid just didn't sound right to people. So they left the UR there. Still ends with ic acid, though. Chlorine becomes what? Chloric. So hydrochloric acid. And bromine becomes bromic. Questions on any of those, ladies and gentlemen? All still binary? Write the formulas for these four, ladies and gentlemen. What does every formula need to have after it?
AQ.
AQ. Do not forget the AQ or I will mark it wrong on a test.
That's the most interesting thing I've ever heard of. And then my roommate.
Yep.
That's what you should do. You forgot the roommate part. My roommate decided to shoot up. What's the charge? You guys should just get married already.
So again, we're still balancing off charges. Hydrogen is always a plus.
Laura Middles.
Hydrogen is a minus 3. So now, right, this is the formula. That is this huge gap, right?
I think we should bring that.
We never write ones. Never write ones. So if it's -1, then it's going to be H and whatever that symbol is. Okay. So now what is the charge of item? Okay, so
Have you never heard of hitting the clock before?
no, but again.
I didn't know the
consider
name.
this. So what was the final formula?
Dude, there's a kid in elementary school called Liquan. That's his name. So every time I saw him, I
Okay,
said,
now what's the charge of carbon?
Liquan. And then he got
You still gotta balance off charges.
Actually, you're wrong. GOG stands for.
All right. What does the formula of every acid, what does the formula begin with, ladies and gentlemen? H. What's its charge? H is always a +1. Okay? So hydroiodic acid, what is the other part? What is the negative part of that? Where do we get the iodic from? Iodine, what's its charge? -1. So that formula is going to be HiAQ. Again, we will never put anything by the second element in an acid unless it's part of a polyatomic. Okay? So the only place there will ever be a subscript is by the hydrogen. Carbonic. What's the carbonic come from in hydrocarbonic acid? What's its charge? -4. So therefore we have H4CAQ. Hydrofluoric acid. What's the fluoric come from? Charge? -1. Hydronitric acid, what's the nitric come from? Charge? Questions? Okay. Now, here's the other thing, ladies and gentlemen. We technically could use any non-metal except for oxygen and the noble gases to write an acid. Okay? But I have never heard of hydrosilicic acid. Okay? Doesn't mean we couldn't give you the name and have you write the formula, though, because writing the formula comes from, okay, hydro, begin with H, siliconic, silicon in it, -4 charge. You could write a formula for it. Doesn't mean that every acid that we could possibly name would exist. Doesn't mean that every formula we write, that acid possibly exists. But understand, the naming system is one that is based off of hydro at the beginning if it's binary, ending in ic acid if it is binary as well. Okay? Question. Now, because hydrogen is acting like a metal, You could also put it with a polyatomic ion. Now it becomes what we call a ternary acid. Okay? So now it becomes what we call a ternary acid. Okay? Now, when we are doing ternary acids, okay, we base the name completely on the polyatomic. Completely on the polyatomic. So ClO3, what is the polyatomic ion called in this compound? What? Chlorate. Chlorate is the polyatomic. Okay? So we find the name of the polyatomic ion in the acid. We are going to name the acid based on the name and the ending of the polyatomic. And here is the rule. Any ATE polyatomic becomes an ic acid. Any ATE polyatomic becomes an ic acid, and we do not begin the name with hydro. So that is the entire naming system. If it is an 8 ending, it becomes an ic acid. So this is chlorate. That becomes chloric acid. That's it. Chloric acid. If your ending is an ITE, it will become an OUS ending. So if this were chlorite, it would become chlorous acid. No hydro, either an ic ending in it or an OUS ending in it. So you can have hydrosulfuric and you can have sulfuric acid. Two different acids. Why? One is binary, one is not. Okay? Prefixes like hypo and per are still written. So if this was hypochlorite, it would become hypochlorous acid. Now here's the good news. What can't become acids for polyatomics? Water is not part of a polyatomic. What must the polyatomic end in to become an acid? ATE. So the ones that end in IDE, we're not going to worry about them ever becoming acids because we have no way to name it with this system. So hydroxide cannot become an acid. Cyanide cannot become an acid. Okay? Our system involves ones that end in ATE or ITE. So again, here, chlorate, ClO3. That means our acid is going to be chloric acid. We name it entirely based on the polyatomic.
We just ignore the hydrogen in the front.
We're not ignoring it. We're accounting for it by saying chloric acid.
Okay, but it's
We don't begin with hydro, though, because then we would confuse this with hydrochloric acid, which is just hydrogen and chlorine. Okay? So if it's not binary, we don't begin with hydro. Okay? That is the way we distinguish between a binary acid and a ternary acid. Binary acids' names begin with hydro, and then they have one other element with them. No hydro, it's a polyatomic. We got to find it on the back of our periodic table. Michaela. I'm sorry? That is an L. That is an L. Cl and O. Okay? Questions? So what is NO3? Nitrate. On the back of your periodic table, NO3 is nitrate. So as an acid, what would this become? Nitric acid. An AT ending becomes an IC acid. Nitric acid. No hydro in front because it is not binary. It has a polyatomic in it. Okay? Questions? HNO2. What is NO2? Nitrite. So what would our acid become?
Nitrous.
Nitrous acid. So again, the last one was nitric because it came from nitrate. Now that we have lost an oxygen, it becomes nitrous acid because it came from nitrite. Naming it all based off of the polyatomic. Question. SO5. What is the name of SO5 as a polyatomic? What? Persulfate. So what would our acid become? Persulfuric acid. Again, we're naming it entirely based on the polyatomic. If there is an AT ending at it, it becomes an ic acid. If there is an IT ending, it becomes an OUS acid. Questions? Steel. What polyatomic does that come from? Hypocarbonite. So what would the acid be? Hypocarbonous acid. There you go. There's your naming system for acids, ladies and gentlemen. Either it begins with hydro and ends with ic acid because it's binary, or we take the name of the polyatomic and we change it to end in ic if it's an ATE, or OUS if it's an ITE. Questions? So now we're going to write formulas. So now from the name, we need to figure out what polyatomic is involved. Acetic. What? Acetate. Because the ic ending means it came from an ATE ending. Acetate. All right, what's the formula for acetate? What's its charge? Okay. So, an ic acid came from an 8 polyatomic. Acetic means it came from acetate. Acetate. C2H3O2, and it's a -1. We're going to put it with hydrogen still. Why?
Because it's an acid.
All acids begin with hydrogen. There's your formula. HC2H3O2. But remember, we still need to balance what? Charge it. But this is a +1 and a -1. They cancel out. Okay? They cancel out. Questions? Sulfuric acid. What's it come from? Not sulfur. Sulfate. If it were hydrosulfuric, yes, sulfur. This has to be some polyatomic. So what polyatomic is close to sulfuric? Sulfate. Okay? Sulfate. So what's the formula for sulfate? SO4. What's its charge?
-2.
So when you put it with hydrogen, what's your formula? H2SO4. Please don't forget the aqueous at the end. Okay? Again, acids always have aqueous at the end of them. H2SO4, aqueous. Now again, if I were you, on your periodic table next to where you had binary acids begin with hydro. The rules for ternary acids are simple. If the ternary ends with an ATE, it becomes an ic acid with no hydro. If the ternary acid ends with OUS, or I'm sorry, ends with IT, it becomes an OUS acid. No hydro again. Nitrous acid. OUS ending. Means it came from what kind of polyatomic? So what polyatomic did it come from? Nitrite. What's the formula for nitrite? Okay, what's its charge? So what would be the formula? HNO2. AQ. Or aqueous. Please remember, we're still doing the crisscross method. But really, the only charge you have to worry about is the one on the polyatomic. That charge will become the subscript by hydrogen. Hyponitrous comes from hyponitrite. What's the formula for hyponitrite? NO -1. We still put it with hydrogen. Formula? HNO aqueous. Questions? Sulfuric. What's it come from? Persulfate. What is persulfate? SO5 -2 charge. Put it with hydrogen. H2SO5 aqueous. Acids are not that hard to name. The biggest mistake is people get a binary and a ternary acid confused. Questions? Look at that, I can't go any further, ladies and gentlemen. That's it. You've got about, yes, Michaela.
Where's the 2 come from after H?
The 2 comes from the charge by the SO5. We're still crisscrossing. Okay? We're still crisscrossing to balance off charges. So this 2 comes down by the H. But the nice part is this is a +1. So we will never write anything by the second part of the compound. If it's a lone element, we won't put anything by it. If it's a polyatomic, we won't put anything by it. You'll never see a polyatomic or an acid with parentheses around the polyatomic. You don't ever need to. But you will see an acid with a 2 by it, a 3 by it, possibly a 4 by it. That's about it though. Okay? Because it's balancing off the charge of the negative part still. Okay? All right, ladies and gentlemen, you have got about 15, 16 minutes, ladies and gentlemen. The worksheet is in Google Classroom on acids. Don't want that.
spinach, meat, like
Yes. I will have to go grab one.
yeah, I need one too.
So here are your acids, ladies and gentlemen. And again, please remember, control in a comma makes a subscript, control in a period makes a superscript, and all acids end with AQ after them. So we need 2 charging blocks. Let's see what I got.
I just got these home. They've been doing. Barely came out with some black rice.
Sorry, I have none. So hopefully somebody has a charger. You can go move back to at the lab stations if you want. But I do not have any charging blocks. So.
Oh, yeah. We're thinking, are you gonna ask them? We're having to ask them about the home base. Can you go over the stuff?
Do I have a baby?
What do you mean? No. Oh. This was not yesterday. This was yesterday. Saturday.
Right.
Please use your time wisely, ladies and gentlemen. Again, if you got a 20 out of 20 on the quizzes so far, you've got this down. There is absolutely no problem. But if not, you have some room for improvement, ladies and gentlemen. And now would be the time to work on those things instead of watching videos of the football game from yesterday or tattoo artistry or things of that nature, ladies and gentlemen.
Wait, did the hackers win? Oh, so we get a free French fry.
I'm not gonna find anything other than like cross country there or just like